Okay, so this is our second day graphing quadratics. Everyone has a warm-up. Go ahead and pause the video and work on the warm-up. Okay, so it says graph the equation. Oh, homework tonight is pages 10 and 11 in your packet. It says graph the equation on the grid provided, then explain the shift of the graph. So if you just type this into y equals on your calculator and went to your table, you would see a vertex at -6, -2. And you would have points here and here. If you recopied your table, that would look like this from your calculator. It would be -6, -2, -7, -1, -5, -1, -8, 2, -4, 2. And again, this is just second graph to look at your table. Okay. My transformation is left 6 and down 2. I have a vertex, while we're noting it, of -6, -2, and we've got an axis of symmetry at x equals -6. Number 2 asked us to find A, H, and K, or not A, just the vertex H and K. Now all these A values are 1. So the vertex for 2A is going to be 4, 1. H is 4. K is 1. And that makes the equation y equals x minus 4 squared plus 1. The vertex for B is -3, -5. That makes H -3 and K -5. And our equation is y equals x plus 3 squared minus 5. All right. Let's take a look at today's lesson. These are the answers to last night's homework. Hopefully it went pretty well. Page 5, page 6. All right, page 7. So this is the equation we were looking at yesterday, but yesterday all of our A values were 1. Today we're going to start to look at what happens when A is not 1. I want to remind you that your parent graph is just y equals x squared. And the table we use for that looks like this. Make a little note. Everybody write this down. If I don't see this in your packet tomorrow, I'll be very sad. You'll be very sad too. Oop. 1, 1, 2, 4. And all I'm doing is squaring these numbers, like not fancy or anything. Okay, so if we make a -1 and we've got y equals -x squared, predict what will go on the graph. So if I took all of these values that were just x squared, I'm going to recopy them here. So this is y equals x squared. -2 was 4. If I now make this -x squared, if I put a negative in front of this, -2 now becomes -4. If I had the point -1, +1, and I put a negative in front, what happens? The y value becomes negative. 0, 0 is still 0, 0, but what about 1, 1? What does it become? It becomes 1, -1. 2, 4 becomes 2, -4. So let's graph these points. Here's -2, -4, -1, 1, 0, 0. And now we see that the graph opens down instead of opening up. So let's make a little note here. Everybody write onto the side. When A is negative, the parabola will open down. All right. So now we're going to put a different number here. We're going to put 2, -2. So go ahead, either use your parent function and multiply your y values by 2 and by -2, or you can use your calculator and type them in y equals. Go ahead and do that now. will become 8. This will become 2, 0, 0. Oh, that's really ugly, sorry. It's a little better. So I can see that here 2 made the graph kind of thinner and gave it a vertical dilation. Now here, it's going to flip it over. 4, 6. Oh man, I don't have enough room. 2, 4, 6. So 8 will be like here. That's sad. 2, 4. Yeah, was there enough here? 2, 4. Yeah, that's weird. I missed. Sorry, it's hard on the slate. Alright, so let's turn the page. Alright, so on page 8, it's the same thing, but now instead of multiplying by 2, I'm multiplying by 1/2. So, again, either put it on your calculator or use the parent function. So this would be 2. And then this is going to be so let's see, we've got 0, 0. So here we can see the 1/2 made the graph wider. All right, so underneath those 2 problems on number 8, it says, what does the effect of A have on a graph? So let's make a little note. Everyone write this down. If A, I like to put it in quotes because that way I know it's not like it doesn't say if A is bigger than 1, the graph has a vertical stretch. It looks narrow. If A is smaller than 1, the graph has a vertical shrink, aka it kind of looks wider. Alright, so let's put these together in vertex form. I'll wait for you to write that down. Okay, so it says try these. So go ahead, pause the video. I want you to type these in your calculator. I want you to get the transformation, the graph, and also the vertex and the axis of symmetry. Okay, so if you graph these on your calculator, here are your A, H, and K values, and here are your, and here are your graphs, and let's just make a little note that here we have a vertex of 3, 4, and the axis of symmetry is x equals 3 because it's this vertical line that goes down the middle. Here we have a vertex of -5, 2, and the axis of symmetry is x equals -5 because it's the line there. Here we've got vertex of 2, -4, and our axis of symmetry is x equals 2. So go ahead, I want you to work on all of page 9 in your groups for about a couple minutes, and then I'll reveal the answers. Okay, so here's the answer to number 4. and the vertex is -1, -4 with an axis of symmetry of x equals -1. Here we've got a vertex of -3, -1, and an axis of symmetry of x equals -3. Number 6 has a vertex of 3, 2 with an axis of symmetry of x equals 2. Oh, sorry, 3. Woo. All right, so here are the answers for 7, 8, and 9. Homework tonight is pages 10 and 11.